Hi everyone, and glad to meeting you guys again. So today we're giving a short presentation about our latest work. So basically, currently, we're working on something really interesting about decentralized business intelligence with the AI agent. So currently, we are working on. So basically, we're looking about a $1 trillion business. So this is a prediction about AI and AI agent is going to happen in the next 10 years, basically. So you can see we are actually at the beginning, only a few $1 billion at the moment, but ultimately it's going to be over $100 billion business. And on the deployment side, so more than half of those AI agents will be deployed on the cloud. But there was one cloud, we know that, is AWS, Google, Amazon, right, and OVH. But for everybody who is here, we have another cloud who is emerging and it's happening, is decentralized cloud, which is decentralized AI, decentralized storage, decentralized computing, etc. And actually, Swan has already been in the decentralized AI research for a couple of years. We have already successfully deployed those AI projects. Previously, they are projects. Now people call them agents. So, for example, large language model, stable diffusion, music generations. Basically, those are API-based. You can deploy it on the remote servers. It can be in data center. It can edge computing computers, and you can use the API to interact with them. And for example, for large language models, LLM, I think a lot of people were talking about Llama. And fortunately, we get something running as well. And I can show a demo later. So how it works, actually it is a multiple market. So a Swan ecosystem, we create, we think there were 3 layers. The first layer is the computing providers. So basically what you're doing is you have computing providers dedicate your resource like memory, GPU, bandwidth to the network. And about that, there's another layer we call marketing providers. So what we see now, the problem is we don't have enough demand. So everybody was talking about decentralized computing, but where's the demand? On the demand side, we think it's just an effort of the community. We need people building different market. Filecoin essentially actually is a storage market, right? Other than storage market, there are AI computing market. There are ZK computing market. So for now, we spent 2 years doing a decentralized storage market. We're building the IPFS with Filecoin as an archive layer. So one problem is how to find those providers and how to give them scores, reputation layer. So at the end, we're doing an auction engine to matching the different providers with a specific price. The same algorithm we can apply to the computing layer. What we do is we're converting all the data centers to a public cloud with Kubernetes technologies. Then each computing providers can give you themselves a pricing. For example, I want $1 or $2 from my 1 gigabyte instance, and with different locations, resources, bandwidth, the auction engine can match the demands. You can send a bid. So I want 1 GPU, but I want 3 top bidder to be selected. So we're building the AI engine, and we're using IPFS and Filecoin as storage layer. When people, the providers get the computing jobs, they're downloading from IPFS and the Filecoin, and after downloading, it can run in the jobs as a container on top of their data center infra and give inference checkpoint, and you can run in use AI jobs and get a result like stable diffusion, etc. On the other side, you can also doing auction engine on the ZK side. So we'll be able to aggregate different ZK jobs from different chains. The first one successfully running is called is the Filecoin ZK-C2 program. We call it the Edge Computing Providers, ECP. The Edge Computing Providers can run on low configuration of computers, even PCs. So basically, because its job is relatively simple and easier. So it doesn't really need much resource. It just need one GPU. So it's become a component of edge computing nodes. So we have edge computing nodes, we have fog computing nodes, which run in data center, and we have a computing market. And we already finished, and the Arleo project was up online several days ago, and we already see the community members from us start deploying Arleo mining nodes or proof nodes on top of our infra on the FCP level. And how we can make it happen, right? So the important part is like how can you persistent data? So we are using smart contracts level. When people start acquiring resource from the network, you need first to put some prepay some tokens, and it will be like in a smart contract. And after the computing provider bidding for jobs, and the computing provider also requires some collateral, right? For Filecoin people here, you're very familiar with collateral. Our protocol is pretty similar. We also have a collateral system, but we don't asking for about 180 days holding time. It's like after the job is finished, 7 days, you can get the collateral back. The more tasks, the more jobs you're taking, the more collateral you need. And all the data and the jobs will be archived on IPFS Filecoin layer. So you can see, you can come back for auditing and the claim purpose. We can check what exactly is running the jobs and who taking the job, and if it's a failure or something doesn't really do the work we want, you can using the archived data or the hot data on IPFS to do a slashing. You can slash in the provider's collateral if they don't provide the result you want. So that part is a little bit tricky, but that's how it works. And for now, we already have over 2,000 nodes running globally on the testnet. We successfully get 2,000 providers running with 100 locations. And we have a CPU resource about 60,000 with over 700 GPUs dedicated network. And we have in instance memory about storage about 2.7 petabytes and also 400 terabytes memory. So which is amazing. We will be able to provide a full computing network globally. Yeah. So this is how it looks about the large language model, which is running on an edge computing instance. We can check where it's running. On space details, you can see the data actually is running on North Carolina, which is Air 40S instance. So you can see like the best food in Brazil. Hope I spelled correct. This is the result. Anyone try this? I haven't tried this. The ones I have no idea. So, but this is how it works. So where does the code hosting? So basically, like we have a space card. You can describe how it works. Basically, it's a Web3 version of Hugging Face. And you have the difference, like for the files where we're hosting. We're hosting on IPFS. You can get the CIDs, and you can get all the deployment files and everything. And if I want fork your work, there is a fork button, and you can fork the work. And there are 20 people already viewed the instance, which is quite interesting. And how about if this is another one, music generation? I don't want to play with this one, to be honest with you. I don't know what kind of music it's going to generate. For example, birds sing. Happy? I'm not sure like how birds will be happy, but that's how it works. Either we are doing the rendering services in remote machine, and you can downloading the services to your local machine. You can see like it's running on a 3080 machine, and yeah. Where it's generating, I can see we have 3 providers: Quebec City running the providers. So let's hear about it. Not sure it's happy, but that's how it works. And luckily, I'm not a big fan of music. Okay, and this is another about the image generation. So let's still doing birds. Birds in sky. Yeah, it's generating instantly. So basically, using those architecture, we will be able using the computing power of the world. And about the storage layer, we are using our own storage. We call it multi-chain storage, which we have developed 2 years ago. It's still working. So all the data we currently hosting on IPFS. And if you want to go to check the detail of the data, so we have some information. You can see like the data was a backup on Filecoin nodes. And so in this way, we indirectly like backup all the important data, including the models, computing, result, jobs, everything. So to become a fully decentralized system. And for other spaces, you can try here. And yeah, like look at the people, what the people currently doing, right? If you take our dashboard, you will see like we have a very heavy usage of GPU. Over 90% of GPU currently using in testnet. Probably reason because the testnet people don't really need to pay real money, but on mainnet it will be different story. So I take a look about what the people is currently running. I see like there is space like this, the old day Super Mario. Yeah, I'm not a good player, so yeah, it's moving. But anyway, I don't know how to play this game anyway. And then others you can see there's a whole bunch of audio mining pool is running. The people is running it to gain the reward about the mining. Let me check look at one of them in the running status. Yeah, look at this guy. He's using our GPU, getting some income from audio network. So basically, like we can do the same thing for Fluence, for audio, for I don't know, whatever ZK Sync, any ZK proofs. So we're very confident with the great network we have been building, we can hold all the computing jobs or all the ZK jobs from all the chains. Yeah, so that's the work we have been done here. Yeah, thanks.
Fantastic. Fantastic. This is great. So Charles, how many of these are Filecoin miners that are providing GPUs and CPUs to you?
I think more. I think maybe 50%. Yeah, because there was I know like.
So 1,000.
Yeah, exactly. And then they are still waiting for the mainnet launching. After mainnet launching, they are adding more GPUs, more servers yet. And yeah, because we are OG players of the Filecoin. Actually, there are lots of, you see those candle algorithms, those spaces contributed by Filecoin ecosystem players. They're building a fantastic job. We have a SDK, and also there was a book created by them called Awesome Swanchain. Yeah, and those merged all the different codes, deployment. So yeah, to reduce lots of work for us.
And what do you need from the Filecoin community to help accelerate adoption of Filecoin as a storage target? Because what I understand is that right now you have an on-ramp, but it is more centralized, right? The on-ramp?
Exactly. We are looking, so for now we have a multi-chain storage as our hot storage layer. However, the multi-chain storage is hosting on one of the computing nodes we had in the network. So how to distribute it, the storage layer, or Filecoin community have a better hot storage layer. On the Filecoin side, actually, I'm fine with that. But for the hot storage, how to make it more decentralized, or like gateways, or more like less latency, different regions. That's a solution we are looking for from Filecoin community.